So we're going to do our second V-sub problem here. I'll do it like boardwork style and you'll see what I mean by that in a moment. But first, I have a couple things that I want you to do. This goes back to like middle school, probably. Do me a favor, simplify root 20. Okay, we know 20 is 4 times 5, and then I can move the 20 out and apply the root to it and get the square root of 4, which is 2 root 5. You could also think about it as, it is root 4 times root 5, because that's something that we can do with roots, and then the root 4 becomes a 2, and I get a 2 root 5. I like to think of it as just sliding this guy out and making it a 2. Anyway, usually we go this direction. Sometimes, like now, it's nice to do the opposite. You may say, what? Well, let me show you. Say I had 3 root 2. I want you to do the opposite. Get it so that everything's inside the root. Okay, hopefully you said, well, when the 3 goes in, I do the opposite of the root, which means 3 squared. So I get 9 times 2, which gives me root 18. Did you get that? Thumbs up. Good. Say, let's do one more. Let's do 5 root 7. Yeah. Made that up. Can you tell? All right. See if you can do it. Okay, 5 goes in. I get root 25 times 7. That's messy, but I can do 25. What's like 7 quarters? That's 175. I got that. All right, so hopefully you see that. What if I gave you something like x root y and asked you to put everything inside of the root? Go ahead, see if you can do that. Okay, hopefully you got root x squared times y, because when I move it in, just like the 5 became a 25, I had to square it, the x becomes an x squared. So let's do one more. Let's do 1 over x times root x to the 5th times y. And this may show you why it might actually be good to be able to do this sometimes. Okay, well, I can move that 1 over x in. So that gives me root 1 over x squared times x to the 5th times y, which gives me root x cubed times y. Now, it's not nice. It's not nice at all, this thing, but it's definitely better than this, right? All the x's are contained in one little spot. So you will have to do this in the one that I'm going to give you right now. So let's do, here we go. X, and before I write this, you have to show, 1, this is a V-sub using the same V that we did in the last one. 2, you have to show that let V equal work with those 3 lines. So x y prime equals y plus 2 root xy. Oh, there's our root. So here's what I want you to do. I want you to hit pause and solve this, and then after you solve it, hit play again, and I will let the answer pop up, just like we do with a lot of board work. If you got it right and you're good, then you're good. If you want to see me go through the whole problem, then I will do that. So hit pause. Okay, here comes the answer. Bam, that's what I got. So now I'll walk through the whole solution method. So the first thing that I do is divide by x. That gives me y prime equals y over x plus 2 times 1 over x times root xy. Now, this guy right here, I'm going to slide it into the root just like I showed you up above. So this gives me y prime equals y over x plus 2 my root gets a 1 over x squared times an x times a y. And then that simplifies to y prime equals y over x plus 2. And then when I divide it in, I get root y over x. This tells me that I should try this v sub with a y over x. For some other thing, say I got x minus 4y everywhere, right? You know, I had x minus 4y plus root x minus 4y plus x minus 4y to the 8th. If I saw something like that, I'd be like, oh, maybe I should use x minus 4y. Now, look, I see y over x is everywhere, so maybe I should use a v equal y over x. So, next line, let v equal, and I should say, I'm only going to make you do these. We're not doing other ones. So, let v equal y over x. Now I multiply, that gives me x times v equals y, and then I'm going to derive with respect to x. That gives me 1 times v plus x times dv dx is equal to dy dx. So now I'm going to sub some stuff in. This will become a v. This will become a v. And then, this y prime will become what y prime is here, which is all of this. So when I do that sub, I get v plus x times dv dx equals v, that's nice, plus 2 root v. So what do I do now? Well, I can cancel this with that, subtract it from both sides. Then I get x dv dx equals 2 root v. How do I solve this? This is what typically happens with these. Typically, I get after I do my v sub, I get something that's separable, and this is separable. So when I do my separation, I get dv over 2 root v. That's by dividing by the 2 root v. And then I'm going to divide by x and multiply by dx. So that gives me equals dx over x. Now I can integrate both sides. Left side goes with respect to v. That's really nice because 1 over 2 root comes from the derivative of root and I got the right d's. So this is just root v equals ln absolute value of x plus c. I keep dropping my absolute values when I have ln's, and I apologize. I shouldn't, but it's just a problem I have. So that gives me, I'm going to do it like this. Root y over x equals ln absolute value of x plus c. And then square both sides. That gives me y over x equals ln absolute value of x plus c. And now I just got to, squared. And my last step is to multiply by x, and I get y equals x times ln absolute value of x plus c close squared. And that is what we have up here if I put my absolute values. So, ba-boom, ba-boom. Hopefully you're good with that, and we will do another video for the next one.